One of the most fascinating ideas in all of math to me is the fact that the square root of something is an actual quantity. Like, if I told you to go out and buy the square root of 20 graham crackers for our cookout, like, first of all, don't come to that cookout, that's weird. But second, you would have no idea how many that actually is. And you may remember from other classes, well, you can reduce the square root of 20 and actually rewrite it as 2 times the square root of 5, and that's true. Those are exactly the same number. But again, like, I still don't know how many marshmallows is 2 times the square root of 5. And so since we don't know what the square root of 5 is just intuitively deep down in our souls, it's hard for 2 times the square root of 5 or square root of 20 to really mean anything for us. This is where this really cool estimation tool comes in, and it's pretty intuitive and pretty straightforward, and it might even feel easy for you, but it's not. You're just good at this. So, the square root of 4, we already know that that's a perfect 2. Square root of 9 is a perfect 3. 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. And square root of 64 is 8. What I've designed here is almost like a number line, and you were asked to do this for your Do Now. This is where it gets fun. The square root of 20, like, one really bad guess for the square root of 20 would be that the square root of 20 is 5. We know that it's not 5 because the square root of 25 is 5, so the square root of 20 can't be 5. But this is cool because you can kind of see that the square root of 20, it just really wants to live on this number line in between some of these other values. The square root of 20 wants so badly to fit in right here between the square root of 25 and the square root of 16. And those are things that we do know and we do understand. We know that the square root of 16 is 4. We know that the square root of 25 is 5. And so it makes sense that the square root of 20 would be somewhere between 4 and 5. And in fact, since it's kind of about exactly halfway between those 2 points, a really good estimation for this would probably be 4.5-ish, like halfway between 4 and 5. And if we do it on our calculators, and I'm going to do this and cheat right now, you'll find that it's very close to that, but that I'm not perfect. So let me go and find the square root function. I have to turn my phone sideways. Square root of 20, 4.47. So even though I'm wrong, like, I am very close. And even 4.47 is not perfect because it's actually 4.47 with a whole bunch of other numbers after it. So using that same process, we can estimate the square root of 37. Well, 37, you can tell, wants desperately to live somewhere between the square root of 36 and the square root of 49. Now, you might be tempted to say that since you know that the square root of 36 is 6 and the square root of 49 is 7, that the square root of 37 would be approximately equal to between those two, like 6.5. And that's not the worst guess in the world, but it's definitely not a good guess, because 36 and 37 are right next to each other. And 37 and 49 are very far apart from one another. So it's far more accurate to guess something like, I don't know, 6.1. And again, this is arbitrarily chosen. This is not perfect. If I pull out my phone again and get the square root of 37, it takes a little while. I get 6.0827 with a whole bunch of other things. So again, not perfect. And that's okay, because at least now I know the square root of 37 is about 6.1, and if I show up with 0.01 marshmallows off from what you wanted for your cookout, we're going to be okay. Also, stop ordering square roots of marshmallows. It's weird.